things in the EDA side? Hello.
Yes, yes.
Okay, cool. So similar way we can also perform on this notebook also, but here we are taken some of the statistical way of the plotting. So here we are going to do some kind of the distribution plot. This will going to give us something called bar plot split and also something smoother function or smoother curve here. So which is going to be help us like how exactly the distribution is going to be for this future. So we are taking something called normalized losses, right? So it's almost like a Gaussian distribution. If you don't know the Gaussian distribution, that is fine, but just for now it looks like a bell curve. Okay, so this also something looks like a bell curve, right? So that's how we are going to assume. If it's something like a skewed means it is going to be distribution like a tail wise. So let's let's Google search for that. See, so this is the left skewed, so which is going to be very tailed in terms of left side. So that's why it is called as a left skewed, and right skewed is nothing but whenever you encounter some of the tail, which may not be a bell curve, but it's going to be well enough to get some kind of information on the tail wise. Okay, so that's why we call it as a right skewed and the left skewed. So in these plots we may not get good results in terms of model building, so we have to be very careful about that. That's why we are going to get these plots, because of the distribution plots will give the intuition behind Gaussian or not. Similarly, we can also perform some of the KDE plots. So KDE plots will going to be help us whenever you need to analyze by using some of the density values. So density is going to be give as something results whenever you require, right? I mean, in terms of you have to calculate it, or you have to add addition to the whatever the model building purpose. So at that time, you have to give these KD plots. Similarly, we can also plot joint plots, which is going to be help us like a how does this distribution is going to be, or else how does this data points going to be split in terms of engine size and some of the horsepower. This is just toy data set. You can ignore that part, but just basic analysis we are going to this plotting. So here you can see some of the engine size may not be accepted by these horsepowers. These are outliers, we can say. So you can see this plot. This is completely skewed right. So it may not be a Gaussian distribution, and this is also something called left skewed. So in these cases, we may not be encounter these features in terms of model building. We have to convert it by using some of the, I can say, transformations. We have we have concepts called the transformations, which are going to be help us. Like different transformations, we have techniques like log normal transformation, box plot transformations, which are going to be help us to convert from this skewed to the Gaussian distribution. Then we can perform the whatever the models we are going to. So at this time we cannot perform. I can say if you perform also, then this will going to get the bad results. Similar way we can also plot by using the joint plot, but here we are using something different kind, right? Here we are using scatter, and this is the different kind. This is X. So here also we can see these are some of the outliers which we are also going to be ignored at the time. We're going to see how to remove that outliers. So this is one of the next chapters which we are going to discuss. Here also we cannot perform. This is also right skewed and left skewed. So how does this going to be help us in terms of model building? If you perform these plots going to be well enough, or I can say in terms of future engineering and future importance wise, this is going to be very helpful, because every time you don't want to check all the things, right? So before doing some kind of cleaning and the pre-processing steps only, you have to perform well, otherwise is it's may be dumb to that model, it may not be works well. So similar way we can also perform on the third node. Yeah, like a distribution plots. So if you ignore some of the values, whatever the values, missing values or some of the values in your data sets, it will give something like this kind of plots. So here you can see here, here you are getting one bell curve and here you're getting one bell curve. So how does this going to be help us to understand for in a one variable? This is a just averaging rating variable. So how does this going to be help us? We don't want to be like a two curves in a one future. So we want to ignore this one, this is completely outlier, I can say. We want to ignore this feature, I mean this plot, we have to extract from this only, because otherwise it may not be helpful by using this value, right? These results may not be helpful with that, but until unless you are getting or starting with one value, this is fine. But most of the values are lying at zero here, that may not be helpful factor us. But we just want to remove this outlier, then we can perform this feature that looks like a Gaussian only.